Hi, this video is going to go through some of the topics and problems in this book. I have it cut off. I'm sorry. It's Pre-Calculus with Limits. Ron Larson and Paul Battaglia are the authors of that, or some of the authors. And I'm just going to go through some of the problems from section 1.2. My assumption is that you have had Algebra 2 in the past. So this first chapter basically will talk about how to graph some equations. It's going to eke out some of the details on what you can tell from an equation. So the first set of problems we're going to do, the first couple, are just how to graph this by plotting points. What I did is I created an XY table. These are the values of X, which is our independent variable. I'm going to plug them into the equation, evaluate them, and that will give us the Y for each of these X's. And then we're going to plot the points. That's the most basic way that you can graph an equation. So we're kind of going right back to the basics. So if I take -3 and I square it, I'm going to get 9, and 9 minus 2 will give us 7. If I put in a -2 for the X value, I'll get 4. 4 minus 2 gives us 2. And just go right down the line. -1 squared is 1. 1 minus 2 is -1. Putting in the 0 will give us a -2. And then watch what happens with these X values. When we square each of these, we're going to get the same Y values as up here. 1 squared is 1. 1 minus 2 is -1. This will give us a +2, and that will give us a +7. So these are each ordered pairs, and we're just going to go over to the graph and plot them. So I'm going to go over to -3, 1, 2, 3 on the X, and go up to 7. 1, 2, 3, 4, 5, 6, 7. And then I notice that down here, I can also plot +3, 7. 1, 2, 3, bring it up to the same Y value. For the X of -2, I'll get a Y of +2. And that holds also for +2 too. I'm going to graph -1, -1, and +1, -1. And then finally plotting 0, -2. And again, if you've had Algebra 2 recently, you should have recognized the equation as a quadratic. And quadratic equations give us parabolas. So you would not have been surprised to see a graph like this evolve. Okay, we're going to do one more of this type where we're going to plot the points to graph an equation. And if you're in my class, I would suggest maybe pausing the video. If you want to do a little practice on your own, write this down, set up your own XY table. And again, I'm just going to start with these 6 points. They're probably the most common points to be tried to be plugged in when you're graphing in this method. We are going to learn a lot more things about equations as we go through this course. So there'll be a lot of other things that you'll be able to determine just from the equation itself. This symbol here is the absolute value symbol, and it means that any value that's inside will become positive when you go to remove these absolute value bars. And again, you should have seen that before in your Algebra 2 course. So now's a good time to pause and try this on your own. So again, I'm taking my X value of -3. The absolute value of -3 turns to +3. And 3 plus 2 gives me 5. The absolute value of -2 is +2. Plus 2 gives me 4. And as you go down, once again, you'll see that this happens. The absolute value of 1 is 1. And we'll have our same Y values coming back again. Okay. So same deal, come over here. This is our X, this is our Y. We're just going to plot the points. If we go over to -3, 1, 2, 3, we're going to go up to +5. I'm also going to plot +3, +5. -2 will give me 4, +2 will give me 4. -1 gives me 3, and then 0 gives me 2. And this is, again, if you've had Algebra 1 or Algebra 2, you should have recognized the absolute value. You'll get like a V sort of graph. Okay, so that, again, is the most basic way to kind of plot or graph points, and that's by plotting points. Okay, another thing that we're going to explore in Chapter 1.2 is to talk about symmetry. And for symmetry, you can have 3 different kinds. You can see the x-axis symmetry. If you have symmetry about the x-axis, that means that if you were to fold the graph along the x-axis, it would match up with itself. And you can see that. The middle picture here on the screen is symmetry about the y-axis. And again, if you were to fold this graph along that y-axis, the graph would match up on itself. And the last symmetry that we're going to study is origin symmetry. So it's symmetry about this point here, about 0, 0. And it's actually as if you fold it two ways. If you fold it along the x and then fold it along the y, that's when it matches up on itself. So that's a little bit different. In our textbook, they have this sort of language, graphical tests for symmetry. And you have to know how to kind of dissect what they're saying. So statement 1, a graph is symmetric with respect to the x-axis if when you put in x, y, it is on the graph of x negative y. So they're saying that you get these graphs to impose upon itself. Test number 2 is symmetric to the y-axis. And this time they're saying that when you graph x, y, it would be the same graph as if you put in negative x, y. And number 3, the graph to the origin, you would replace the x with the opposite of x and the opposite of y. This might be a little more concrete for you. This is also in the textbook, algebraic test for symmetry. The graph of an equation is symmetric with respect to the x-axis when you replace y with negative y. For the y-axis symmetry, you'd replace x with the negative x. And then to test for symmetry about the origin, you would take out the x, put in the opposite of x, take out the y, put in the opposite of y. So let's do a couple of these. And my pencil's in the way. Okay. So symmetry about the x-axis, what they said to do was to take out the y and put in the opposite of y. And again, a lot of people will say negative y. We want to kind of get away from that with the advanced math classes that we're in. Think of it as the opposite of y. So what I'm going to do is I'm going to copy over this original equation, and I'm going to put in the opposite of y whenever I see a y value. The x I'm going to keep the same because that's not the test for the x-axis. There's nothing to do to simplify this, and basically all we're saying is, hey, did these two things match? And it's really clear that no, they don't match. So this was the original. We put in the opposite of y and simplified anything, which there was nothing to simplify. And then we just compare them. They are not the same. So this equation does not have symmetry about the x-axis. Let's try this one here. This problem, we're going to do the same thing. Anywhere we see a y, we're going to put in the opposite of y. So I'm going to copy the x, copy the equal sign. I'm going to put the opposite of y to the fourth, copy that subtraction sign, put in the opposite y. And now we can clean this up. If we have a negative y to the fourth, it means negative y times itself 4 times. Well, if you process that, and again, I'm not going to go through it because this is a pre-calculus class, it will turn positive. Copying the minus sign, and when we square the negative y, it will turn positive. So what we're doing is we're comparing these two equations. This was the original. This was our final after we substituted and cleaned it all up. And we can see that they are matching. So yes, this does have symmetry with respect to the x-axis. The third equation we'll try also. Again, we're going to copy this. Wherever we see a y, we're going to put in the opposite of y. So we have the opposite of y equals x squared plus the absolute value of x. These two, there's nothing to clean up here. So we can see when we compare these two things that they do not match. So this equation does not have symmetry with respect to the x-axis. Let's take these same 3 equations that we just worked with, and one at a time we're going to check symmetry about the y-axis. So symmetry about the y-axis, what we're going to do is wherever we see an x, we're going to put in the opposite of x. And then again, we're going to clean it up. So for instance, in this first example, I'm going to copy it. Whenever I come to an x, I'm going to write the opposite of x. And if you have good math housekeeping skills, what you'll train yourself to do is to put that in a parentheses. And it just makes it a little bit more clear what you're going to simplify. So here I need to clean this up. So I'm copying the y. There's nothing I can do on this side of the equation. But a negative x cubed That's it, times itself 3 times will just become a negative x cubed. What's going to happen to this equation, though, I have, I'm basically going to be doing this. I'll write it out. It's minus a negative 9x. And again, you have to have really good housekeeping skills. So if you had minus a negative x, it turns to plus a positive. So if I just write it out so it's really clear to me, this is what I ended up with when I simplified. So I'm going to compare that to that. Okay, x cubed minus 9x is not the same as negative x cubed plus 9x. Those are not the same things. So this does not have symmetry with respect to the y-axis. Let's go over to this other equation. And again, if you're feeling confident or you want to try this, write this equation out. Substitute in wherever you see x, put in a negative x, and then do the work and come back. We'll hit pause while you're doing your work and then see if we agree. Okay, so again, I'm going to copy this wherever I see an x. I'm going to put in a negative x. The y's are not going to change because that is not how we handle the test for the y-axis. And actually, there's nothing to simplify here. And so I'm just comparing these two things. Are they the same? They are not the same. So this equation also does not have symmetry with respect to the y-axis. And now let's go down. And again, this is another one that would be good to pause. Wherever you see an x, put in a negative x. So I'm going to copy the y. Here's an x. So I'm going to put this in instead. There's another x. I'm going to write the absolute values. Just like that. And now again, I'm going to see if I can clean this up a little bit. So the y can't change, the equals change. But what is negative x times itself? It becomes positive x squared. Copy the plus sign. And what is the absolute value of a negative x? The absolute value of the opposite of x is not going to change. So this will be, doesn't matter whether your x is positive or negative, you're going to get the same value out. So this simplified to that, and now we're just comparing them, the original to our new one. They absolutely do match. So this function would have symmetry, excuse me, about the y-axis. Okay. And then our final test on symmetry will be about the origin. We're going to stick with these same 3 equations. Excuse me. For the test about the symmetry about the origin, we take out the x and put in the opposite of x, and we take out the y and put in the opposite of y. I don't know if my pen's losing ink, but we'll see how it goes. So for this is my original equation. Instead of the y, I'm going to write the opposite of y. Copy the equal sign. And now instead of the x, I'm going to put negative x or opposite of x minus 9. I think my pen is dying. Just grab another one real quick. And now I'm going to keep the negative y. Can't do anything with that. A negative x to the 3rd power gives me a negative x. And again here, I'm going to have a minus 9 times a minus x. So that becomes plus 9x. So when I stop here, I can't really simplify this per se, and I want to compare these. So I have to do this in a smart way. I'm thinking to myself that, well, there's some differences on both sides of the equation. So what I'm going to do is I'm going to see if I can make this y become a negative y. Sorry, I'm going to see if I can make this negative y become a positive y. Then I'll be able to compare it better. To do that legally, I'm going to multiply every single term by a negative 1. Okay, that's the only way to do it legally. So a negative 1 times a negative y gives me a positive y. That's what I was going for. A negative 1 times a negative x cubed turns it to a positive x cubed. And the negative 1 times a positive 9x. If I do a negative 1 times a positive 9x, that's going to make it a minus 9x. So I want to compare this to this. And you can see that they are the same. So this function does have symmetry about the origin. Probably the part that might feel new is from here to here, or rather from here to here. Like we did have something that didn't look like it matched, but because things were different on both sides of the equal sign, we want to see if we can cause this to start in the same way as our original. And that's why I brought this in. And you'll see that that's probably a common thing to do. All right, let's check our second equation here. And again, feel free to hit pause and try this on your own and then come back. So again, I have an x. I'm going to change it to the opposite of x. I have a y. I'm going to change it to the opposite of y. I have another y. Change it to the opposite. So the first thing I'm going to do is just clean this up and then compare and see where I'm at. So the negative x I really can't change. The negative y to the fourth, if I take negative y and put it to the fourth power, it's going to be positive. And this here, I'm going to cover up that minus sign just for a minute. Negative y squared becomes positive y. So I'm subtracting out a positive y squared. So I'm just going to pause really quick and just look at this and compare it to the original. Are things different on both sides? Well, the x side is different, but the y's are exactly the same. So I can tell right away that they're not going to match. But if you wanted to do the same step as previously, where we did run through a negative y, negative 1 rather, negative 1 times negative x gives you positive x. Negative 1 times a y to the fourth makes it a negative y to the fourth, and a negative 1 times a negative y squared. So it won't match this way either. We do have the x's starting off the same, but the signs on the right-hand side are not. So it just reiterates the fact that there was no symmetry along the origin. Finally, let's look at this last one. Again, if you want to hit pause and try it on your own. I am taking the y and putting in the opposite of y, copying the equal sign, taking out the x, putting in the opposite of x, and the same thing in the absolute value symbol. And now we want to clean up. There's nothing to change on this yet. Negative x times negative x becomes positive x squared, plus, and again, the absolute value, in other words, if we have the absolute value of 7, it's going to be the same thing as the absolute value of negative 7. So whether you put in the positive value or the negative, you're going to get the same. So we can just rewrite it like that. So we want to just double check. This side has changed from the original when we compare them. And this side here has stayed the same. So these are not the same. So this function also does not have symmetry about the origin. All right. One other thing we can tell about graphs that's talked about in chapter 1.2 here are finding intercepts. And you definitely learned this in Algebra 1, probably came back and saw it in Algebra 2 as well. So for finding intercepts, if you want to find the x-intercept, what you want to do is put in 0 for y. And to find any y-intercepts, put in 0 for x. Okay, so we're going to do that. Again, intercepts are just where it touches the graph. So if you look at this graph here that we had, this here is a x-axis. I'm sorry, an x-intercept. This here is also an x-intercept. And here is our y-intercept. So we're finding these algebraically. So if we want to find the x-intercept for this one here, we're going to put in 0 for y. So that rewrites as x plus 3 times 0 equals 9. 3 times 0 is 0. So the x-intercept for this equation is at x equals 9. If we want to check out the y-intercepts, this time we recopy this, but wherever we see an x, we put in a 0. So 0 plus 3y equals 9. The 0 is a moot point here, so we're just looking at 3y equals 9. Divide both sides by 3, and y has to be 3. So our y-intercept is at 3, our x-intercept is at 9. If you've taken Algebra 2, you'll recognize this is a line, a linear equation. You could just plot this, and connect the dots. And there's your line. For the second one, y equals x squared minus 1. Again, feel free to hit pause and try the problem on your own and see if you get the same thing that I do. For our x-intercepts, we're going to put in 0 for y. So 0 equals x squared minus 1. Again, this course that I'm teaching, I'm assuming you know how to factor. So we have 0 equals, and this is a difference of squares. So our factoring is x plus 1, x minus 1. If we are solving this, our solutions for x are going to be -1 and +1. So our x-intercepts are at -1 and +1. To find the y-intercepts, we're going to take our original equation and put in 0 for x. So y equals 0 squared minus 1. 0 squared is 0, so y is just going to equal -1. So those are the intercepts for that graph. This one isn't a line, it's a parabola, which we know because we have a quadratic equation. And we'll just do this one more time for intercepts. Again, I encourage you to hit pause as you copy down the equation, figure out the intercepts, and come back and check your answers. So for the x-intercepts, we put in 0 for y. Then what we're going to do is factor out a 3 and an x. And what we can see here is for this part, 3x, that will give us, intercept of 0. And then for the second part, we once again have a difference of squares. So it's 3x, x plus 2, x minus 2, if you want to see it done out. So x will equal 0, -2, and +2. So this one has 3 x-intercepts. For the y-intercept, same deal. We're going to take the equation, and this time we keep the y, and everywhere we have an x, we put in 0. Both of these terms go to 0, so our y-intercept is at y equals 0. All right, so there is how you find the intercepts of a graph. All right. And the last topic that I want to touch on for this chapter is, that's your textbook, or the textbook, is circles. You might want to put this in your notes. There's our standard form of the equation of a circle. They're telling us that if you have any point x, y, and it lies on the circle, this would be your standard form of the equation. So again, that's a good thing to put in your notes if you don't have it. X minus h squared plus y minus k squared equals r squared. They're giving you the center is at hk, and if you take the square root of that r squared, then you will have the radius. So it does tell you quite a bit. There's a picture of the circle too. So let's do a couple problems finding the equation and see how that goes. So to find, we have to write the equation of a circle with the radius of 3 and a center of -5, 7. So here is the standard form. The x will stay an x in our answer, and the y will stay a y in the answer. But we'll have a number for h, k, and r. That's going to be our goal. Okay, so if we know that this is the center, this is our h, and this is our k. I'll do this one out in a little bit more detail than I normally would, but that's okay. So I'm going to copy this and put in values wherever I do. So it's going to be x minus, our h value is -5. Copy the squaring, copy the plus, copy the open parentheses, y minus, the k value is 7, equals, and the radius is 3. So we'll have to square that. So now we just want to clean it up. X minus a -5, sorry, that should have had that, turns into x plus 5. Copy the plus, y minus 7 does not change in the parentheses, and then 3 squared is 9. So you want to be able to go back and forth between having information like this and writing the equation, or being given this equation and recognizing that the center is at -5, +7, and the radius is 3. So those, again, this is an Algebra 2 topic. You should have seen it before, so I'm not spending a lot of time on it, but I just wanted to remind you how that works. This one's a little bit different. We still need to find a value for h, k, and r, but they did not give us the radius. So we need to find the radius. The way that we're going to find the radius is by using the distance formula. So let's just process this. We have the center at -2, -6. I like to label things as I go. That's h and k. And this solution point, that's just a fancy way of saying, hey, this point is on the circle. So it's on the outside of the circle. We know the center. So what we're going to do is take these 2 points and find the distance between us, and that will give us the radius. Okay, here's the distance formula. X2 minus x1 plus y2 minus y1. And we'll use h and k as x2 and y2. And so we'll use this as x1, y1. So the radius, and x2 is our h minus 1 squared plus our y2 is our k minus y1 squared. And now it's just arithmetic, honestly. And start from the inside out, right? -2 minus 1 is -3. And -3 squared is 9. -6, remember, that turns to plus a positive. That's going to be +4 squared, which is 16. And our radius is equal to 5. Okay, so we had to do this little extra work, but we were given the h, we were given the k. We have just figured out that the radius is 5. So our equation of the circle is x minus our h is, where did it go? -2. So that'll turn into a +2. Y minus our k is also a negative number, so that will be a positive value now inside the parentheses, and that will equal 25. So that is our equation. All right, I hope this has helped you do some of the problems in section 1.2. If not, send me a quick message, and I will do the best that I can to help you out. All right.